So the numerical is there are 5 wagons, right? 5 wagons are there and are available, and these 5 wagons are available at stations. Available at stations 1, 2, 3, 4, and 5. And these are required at 5 stations. Other and these particular wagons are required at another 5 stations. So, particularly these are required at 5 stations 1, 2, 3, 4, 5. Right. So the mileages between the distances, or you can say the distances between various stations are given in the table. How should be the wagons? How should be the wagons transported so as to minimize the total mileage covered, the total mileage or distance covered, right? So we have been given a table in which the distances from one station to another has been given to us. Right, so 1, 2, 3, 4, 5. This is 1. This is 2. This is 3. This is 4, and this is 5. Right. So the distances are 10, 5, 9, 18, 11, 13, 9, 6, 12, 14. We have 3, 2, 4, 4, 5. Then 18, 9, 12, 17, 15. 11, 6, 14, 19, and 10. So this was the numerical that we have, and what we are going to do is we are going to solve it with the help of the assignment model. So each wagon is to be transported to one of the stations. So though it is said that how should be the wagons transported, so don't get confused that you need to solve it by the transportation problem. Right. So now here it is an assignment problem because there are 5 by 5 matrix, and the one wagon is to be given to only one station. So there is no splitting of the wagons that is allowed. No, so we can't keep 0.75 wagon to one of the station and 0.25 wagon to another station. That is not possible. So you should be able to again identify which is an assignment problem as well. So in entire this numerical, none they haven't used the word assignment anywhere. So they have used the word transported, so it doesn't mean that it is a transportation problem. So you should be able to identify which is a transportation problem and which is the assignment problem, right? So now what we are going to do is we are going to perform the row reduction, right? So we are going to solve it by Hungarian method, using Hungarian method. What we are going to do is now we are going to perform the row reduction, right? So row reduction, how we do the row reduction? We select the minimum value in that particular row, and then we proceed ahead. And then what we do is we subtract that minimum value from all other values of that respective row, right? So again, 1, 2, 3, 4, 5. We have this as 1, 2, 3, 4, and 5, right? So here the minimum value that we have is 5 in the first row. So 10 minus 5 is 5, 5 minus 0 is 0, 9 minus 5 is 4, 18 minus 5 is 13, and 11 minus 5 is 6. In your second row, the minimum value that we have is 6. So 13 minus 6 is 7, 9 minus 6 is 3, 6 minus 6 is 0, 12 minus 6 is 6, and 14 minus 6 is 8, right? Similarly, moving ahead, the next minimum value that we have is 2 in row number 3. So 3 minus 2 is 1, 2 minus 2 is 0, 4 minus 2 is 2, 4 minus 2 is 2, 5 minus 2 is 3, right? Moving ahead, we have the next row in which the minimum value is 9. So 18 minus 9 is 9, 0 minus 9 minus 9 is 0, 12 minus 9 is 3, 17 minus 9 is 8, and 15 minus 9 is, no, 15 minus 9 is 6. Moving ahead to row number 5, the minimum value that we have is 6. 11 minus 6 is 5. 6 minus 6 is 0. 14 minus 6 is 8. 19 minus 6 is 13. And 10 minus 6 is 4. So what we are going to do next is the column reduction. So we are moving ahead with the column reduction. So we have this as the nomenclature, right? So let's address this. The minimum value that we have in column number 1 is 1, right? So we are going to use that. 5 minus 1 is 4, 7 minus 1 is 6, 1 minus 1 is 0, 9 minus 1 is 8, and 5 minus 1 is 4, right? Similarly, in the second column, the minimum value is 0, so entire column will remain same, right? In column number 3, again the minimum value is 0, so the entire column will remain same. In column number 4, the minimum value that we have is 2. So 11 minus 2 is 11, 6 minus 2 is 4, 2 minus 2 is 0, 8 minus 2 is 6, and 13 minus 2 is 11. In the column number 5, the minimum value that we have is 3. So 6 minus 3 is 3, 8 minus 3 is 5, 3 minus 3 is 0, 6 minus 3 is 3, and 4 minus 3 is 1. So likewise, no, we have finished with the column reduction. Now, if you see what happens in row reduction is that after doing the row reduction, every row has at least 1 0, right? And after doing the column reduction, every column has at least 1 0, right? So this row reduction and column reduction is very, very important. So now what we are going to do is we are going to perform row scanning and column scanning on the column reduction matrix. So we are going to do it in this particular matrix. So I'll be using here only so that it will be easy for us, or I'll be drawing it on the next page. Just a second. I'll be drawing it on next page so that it will be easy for us. Just a second, let me copy the values. Right, so redrawing that matrix. Right, so it was 4 0 4 1 3, so 4 11 3. It was 6 3 0 6 3 0 4 5. It was 0 0 2 0 0. It was 8 0 3 6 3. It was 4 0 8 11 1. So what we are going to do here is we are going to perform the row scanning and the column scanning. So let's do the row scanning. So we have 1 0 in this column. So we have marked it marked with the help of a square, and then we are going to draw a vertical line passing through that column. Right. So nextly, in the next row again we have one single 0. So again we are marking it and then drawing a vertical line. In the third row we have 3 zeros, so here not possible. In fourth row it is again, no, there is no zero absolutely, so not possible. In fifth row there is no zero, so there again it is not possible. So the next step is to go for column scanning. In column number 1, what we have is, we have 1 0. So what we are going to do is, we are going to mark it, and then we are going to draw a horizontal line passing through it. In column number 2 we do not have any zero, column number 3 we do not have any zero, 4 we do not have any zero, and 5 also we do not have any zero. So right, so now these zeros are cancelled, so hence we can check out the number of squares. So number of squares is equal to, number of squares is equal to 1 2 3, and number of columns or rows is equal to how much? It is equal to 5. So hence they are not matching, and hence iterate further, hence iterate further. So we have to identify the minimum value. The minimum value appears to be 1, right? So minimum value identified is 1, right? Reconstructing the matrix, and performing row and column scanning. So what we are going to do, we are going to perform row and column scanning after reconstruction. So let's reconstruct this matrix. So the matrix can be given as, so how we are going to reconstruct the matrix? We are going to add the identified minimum value at the intersection of the lines, and from from all other undeleted cells we are going to subtract it, right? So I'm going to add it first in the intersection lines. So now intersection line is here. So 0 plus 1 is 1, and 2 plus 1 is 3. So there are only two cells in which the intersection of the lines has happened. Now undeleted cells. So 4 minus 1 is 3, 11 minus 1 is 10, 3 minus 1 is 2, 6 minus 1 is 5, 4 minus 1 is 3, 5 minus 1 is 4, 8 minus 1 is 7, 4 minus 1 is 3, 6 minus 1 is 5, 11 minus 1 is 10, 3 minus 1 is 2, 1 minus 1 is 0, right? All other cells will remain same. So here it is 0 4 3 0, here it was 0, here it was 0 0, so here it is 0 0 3 and 8. So now that we have got this, now that we have got this, what we'll have to do here is, will be performing the row scanning and the column scanning, right? So let's perform the same here, right? So row scanning, this is 1 0 here, so I can draw a vertical line. Nextly I have 1 0 here, I can draw a vertical line. Next I have 3 zeros, I can't perform. Here also in fourth I cannot perform. In fifth I can perform the row scanning, and hence I have drawn a vertical line. Now that I finished with the row scanning, I can go for the column scanning. First column has only one single zero, so marking that zero and then drawing a horizontal line. So let me check whether all the zeros are cancelled or not. Yes, all the zeros are cancelled. Let's check the number of squares. Number of squares is equal to, 1 2 3 and 4, and number of columns or rows is equal to 5. Hence iterate further, hence we'll have to iterate further, right? So when we are going to iterate further, minimum identified value is identify the value here. The minimum identified value is how much? It is 3. Reconstructing and perform scanning, right? So I'll be drawing here only 1 2 3 4 and Here we have 1, 2, 3, 4, and 5. Okay, so 3 minus, so no, let's consider the intersection cells only. So 1 plus 3 is 4, 3 plus 4 is 7, 3 plus 3 is 6, 5 plus 3 is 8, right? 10 plus 3 is 13, 3 plus 3 is 6, 7 plus 3 is, oh sorry, we have to subtract, just a second, sorry, 3 minus 3 is 0, 10 minus 3 is 7. Nextly, 5 minus 3 is 2. 3 minus 3 is 0. Right? 7 minus 3 is 4. 3 minus 3 is 0. 5 minus 3 is 2. 10 minus 3 is 7. And all other cells remain same. So it is 0, 4, 2, 3, 0, 4, 0, 0, 0. 7, 0, 3, 2, 3. Okay, here we have 0, 8, 0. Right, so let's perform row scanning and column scanning at this point. So first row it is not possible, second row it is not possible, third row not possible, fourth row, yeah, it is possible here. So we are going to mark this and draw a vertical line. In the fifth row it is again not possible. Sorry that no, the values are not not visible, so I'll be redrawing the matrix again on the next page, and let's avoid the confusion. Just a second, let me copy the values. It was 0, 0, 4, 7, 2, 2, 3, 0, 0, 4, it was 0, 3, 3, 0, 3. Okay, some okay, it was 0, 4, 7, 0. 7, 0, 0. Then it is 4, 0, 3, 2, 2. It is 0, 0, 8, 7, 0. Right? So I guess the values are there. Let's do the row scanning. I've written the right values, right? Okay, let's do the row scanning and the column scanning here properly. So first row not possible, second row not possible, third row not possible, fourth row it is possible, and we are going to put a vertical line. Again, fifth row is not possible. First column again not possible. Second column not possible. Third column, yes, it is possible, and we are going to draw a horizontal line, right? Similarly, in fourth column it is possible. We are going to put a 0 here. We are going to put a square here, and we are going to mark it. Fifth, again it is fifth column it is possible. So fifth column here, and we are going to put a horizontal line here. Again, we have to check after first row scanning and column scanning, all zeros are cancelled or not. No, 1 0 is remaining pending. So we have to do the row scanning. So row scanning, we will be marking this 0 and then we are going to cancel it like this. Now let's check whether all the rows are cancelled or not. Yes, all the rows are cancelled. Number of squares here is equal to 1, 2, 3, 4, 5, and number of columns or rows is also 5. Hence optimal solution achieved. Hence optimal solution achieved. Right? So we'll be writing it in the proper manner as to which wagon will be going from which station to which station. Right? So there are five. No, what was the numerical? Five wagons are available at station 5. Okay. So from station to station and the distance. Right. So according to our this thing, I will be drawing you that. So from one for station number 1, the wagon that is available on the station number 1 will be supplied to station number 1 only. So 1 to 1, and the mileage that we have or the distance that we had was 10 according to our numerical, right? So wagon number from station 2, the wagon will be transported to station number 3, whose distance is 6 kilometers. The wagon from station number 3 will be transported to station number 4, whose distance is 4 kilometer. Wagon number 4 will be transported to station number 4 will transport its wagon to station number 2, and the distance is 9. And lastly, the wagon at station number 5 will get transported to station number 5, whose distance is 10 kilometer. So the minimum distance, that criteria was with us. So here I will be writing minimum distance that will be getting covered is how much it is. 10 plus 6 plus 4 plus 9 plus 10. So we'll be getting it as 39 kilometers, right? So this is the answer. This is the way you'll be writing the answer for this numerical.